Perfect. Okay. Lawyers. Okay, so all right, so okay, so these are the properties we talked about the other day. These are the ones you had to work on your homework. Reflexive properties when they set something equal to itself. Symmetric properties when you switch something around the middle of a math problem, like the entire right and left side switch. I want to show you that one, like how we would technically use symmetric property. So imagine we're doing a problem like this. And so if it said, if 15 equals 2x plus 1, then x is equal to 7, let's say. Okay? So let's say that that's my math problem. And so how we always start the proof, you start with this, equals the 2x plus 1. And so that would be my first line of this proof. It's the given. And what you do is you actually do the math and you solve it outright. But if you're actually doing the math here and you're subtracting one on both sides, that's subtraction property equality. It's over there. Okay. That's what property number 6 up there. Subtraction property equality. To subtract 1, then I'll do division property to get rid of the 2, and eventually you get 7 equals x. Agreed? Okay. So you're doing the work. There's a couple lines of work there. But does that look identical to what we need to prove? No, it's slightly switched. The number's correct, don't get me wrong, x is 7, but the problem is it's switched. So in the next line, going, whatever line this is, maybe this is line 2, 3, 4, in line 5, you have to switch them so it looks identical to what we're trying to prove. This is the line where I can put the little dot, 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 the triangle of dots, the therefore symbol, because that's exactly what I'm trying to prove. And how I went from this line to this line is I did the symmetric property. It has to look identical to what the answer is for what they give you. Does that make sense? Like where you use it. So that was the symmetric property. That was the whole point of it, right? Transitive is when you're taking like two equations and making a new one out of it. It's not it looks like substitution. It's really not. So when you're looking at two different equations and you're making a new third one without having to use substitution for it. It's using logic. Okay. We'll see this one later. I'll bring it up later, like when we start looking at those geometry problems. Okay, so for right now, it's just kind of a different situation. But 4, 5, 6, and 7, that's where you magically do things to both sides of the equation. So like I add numbers to both sides, I subtract, I multiply, divide, that type of thing. Like on that problem over there, I have to subtract 1 to both sides. So that's subtraction property equality. That's what property number 6 here. Then I had to divide, so that's division property equality. And after these, you got to make sure you put property of equality, of equality, of equality, of equality. The ones up here, I don't like that you're just writing these words because we're not going to have another type of symmetric property. Okay, but these we will have more. There will be more addition problems, more multiplication there. Okay. Any questions with the properties of equality that we did earlier last week and yesterday? Okay. Let's get these skill properties. These are the ones we introduced yesterday. Here. All right. So these were the 3 that we introed yesterday. Okay, so the field properties, these are what we do on any type of math problem. It doesn't have to be an equation like those. This can be for expressions, it can be for equations, it can be for geometry problems, it can be for really anything. Closure property. Now what do we call that yesterday? What was the correct term? Instead of using closure, what do we use? Yeah, we use substitution, right? This is any time in the middle of a math problem, you're doing some simple arithmetic. So maybe your problem was, in one of the lines of your proof, you had, 3x plus 4 plus 5 equals 18. You had something like that. But in the next line, you write 3x plus 9. Going from here to here, you just substituted. You took out that 4 plus 5 and you put in the 9 there, because that's what it's equal to. That's substituting, making up a new number and plugging it in. Now, there's exceptions. Not everything is substitution, right? Simple math, yes. Simple arithmetic, that's what we called it yesterday. You know, random numbers added, subtracted, multiplied, or divided. But when they're very specific and they make numbers like zeros and ones, or they add zeros and they multiply by ones, that's different properties. That's the ones we're going to actually introduce today. So that's why I want to make sure that you understand that concept. Any questions right now with how substitution looks for you guys right now? Okay. So that's field property number 1. It's closure, but we call it substitution. 2, commutative. It's when you move things around. How we're going to use this in here. You know, whatever my problem is. So let's say we're doing an expression, and we're trying to simplify a problem down. So it's a problem like this. 4x plus 9 plus y plus 2x minus 3. If this is my problem, the next line that you have to do, so that's my start. You know, it's an expression. There's no equal sign. The next step that I would do is I move things around. I move like the x's next to each other, the 9 and 3 next to each other. So I would do this. 2x, the 9 and the 3, and then I would put that y over by itself. Now I'm grouping things together, that's commutative. I didn't actually add them together. You know, that's the next line that I would do. But this is like grouping things together, getting them next to each other. Okay, from now on, after today, because I know we have work today, from now on we need to start doing this one. Like, don't do it in your head. Actually write it down like you're grouping things together. The reason why that this is helpful is that you realize that you need to bring like negative signs with it, or positive signs. Like when I brought this 3 up with the 9, it was a negative 3. It's 9 minus 3. And when I brought the 2 up, that's a positive 2 with the 4. Just grouping those together, you won't lose track of the sign. And now you know if you're adding or subtracting. That's like the big thing. And then from here we can go further, and those will be the properties we're going to learn later. Obviously the 9 minus 3 is substitution, but the 4 plus the 4x plus 2x, that's actually another property that we're going to do. That's going to come up later. We can't just add variables off the top of our head. You know, most people can do the shortcuts, but we need to learn the correct way to add variables together. Okay. Questions with substitution and commutative so far? Okay, so that's just one property. We'll do that quite a bit. Associative. This is one that I really want to focus on today, because this one I introed yesterday, but I don't think some people understood why. Like why we would ever choose associative. And I tried to give you an example yesterday, but I want to give you kind of a more definitive like way why you would ever see this property, how you would use it. All right, so associative property. So getting away from this type of problem, you know, with commutative and substitution. Associative, and there's 2 types of problems we use it for. Number 1, it's a problem like this. You're going to be adding 2 things together in your problem. You know, whatever this is. And maybe this isn't in it. So maybe this is like adding segments together. So on a picture, you know, this segment was 3x plus 3. This segment over here was 7. And you're trying to find the entire stick. So this is AB, and that was BC. And you're trying to find what is the length of AC. So what you're doing is you're adding AB plus BC together. You're adding the sticks. You're doing the segment addition, right? So to do that, you have to add that. Well, the thing is, this is in parentheses, because that's the entire AB stick. And then you're adding to the other stick. Well, what you have to do first is you have to get rid of the parentheses. Or you have to put the parentheses around the 3 and 7, because those are really the only numbers you can add. That, going from here to here, like either getting rid of the parenthesis or moving the parenthesis, if you have it, that's associative. Most people like just ignore that. They just get rid of them, they try to do the math in the next step. But you're actually moving a mathematical figure, an object, so you have to have a property name to it. Okay, so that's like the number 1 thing where we would technically use it. The other way that you could possibly see it is doing a problem like this. 4 times the 2x. Now, when you're actually multiplying the 4 times the 2x, like you're trying to take some segment and you're trying to like quadruple it, right? Make it 4 times as big. You don't actually take a 4 times the 2x. What you're actually doing is you're taking the 4 times the 2 out front, like that. Going from here to here, that's associative. That's this property. You're moving the parentheses around the digits, and then you're multiplying. That's where you see it. So technically, where you see associative property is right after you distribute. So if you have a distribution problem, you're handing something out to each item in the parentheses. At some point, you'll have to move the parentheses around like this. And so it's 100% guarantee when you distribute, you have to do associative property right after it, because this is what you're going to have to end up with. And now you can do the math from here down. That's distribution. So this is associative. Then you can substitute the 8 in there, and then you go further from there. All right. Questions on where we would see it? All right. Let's move on here. So that's not bad. So those are the basic properties we introed yesterday. And we're starting to see how all these things fit together now. Because they rely on each other. Because obviously, as you can tell, like, as I'm doing examples, like a lot of these, like I'll do a property and then it's immediately followed by another property, like substitution or commutative or something like that. Okay. So, new properties today. New property. We're going to introduce the identities. There's 2 identities today, and I have them labeled right here. So there's 2 identities. There's the additive identity, so there's another addition property right there, and then a multiplicative identity. Now, how identities work? You're using the numbers 0 and 1. As I said, those are special numbers. If any time you're either adding 0 to something, like this, or you're multiplying by the number 1 onto something, that's when you have to use this property. I'm going to try to give you every example where you potentially see this, like how we would technically use this. By just knowing these 2 properties, we've almost, we have 2 more. We have the inverses and distribution. We're almost at the point where we can solve an entire equation all the way through. An equation all the way through. Okay, so it's adding 0 and multiplying by 1 because that doesn't change whatever number you're working with. Now let me show you where you see these. Now these are no particular order, these properties. These are just the main properties from every algebra textbook that I pulled from. Technically, if I'm thinking about like an order, putting these in a certain order so that makes more sense. Substitutions at the top of the list, distributions at the top of the list, closely followed by associative, then commutative, and then I would go inverse properties, and I'd put the identities last. That's usually one of the last things you do in the middle of a problem. But let me show you how you use these, where you'd see this in like an actual math problem. And it's actually used right here. So this is my equation, right? At some point on this problem, I'll have to subtract 3 from both sides. Agreed? Like to solve. So that's the subtraction property of equality. Actually writing this. So that's subtraction property of equality. I'm doing it for both sides. Okay, the next line, on the one side I have substitution. That's 10 minus 3. That's just a random number, right? So plus 3 minus 3. But on this side I have the actual 10. That's substitution. It's random digits. Just doing simple math. Right here, this is special. This is a new property. We're going to actually get this here in a minute. I'm doing the 3 minus 3 idea, and I'll come back to it. But that's a different property. It's not substituting because you're creating that special number 0 here. We'll see that property here in a minute. In fact, I'm not even going to label this property yet. We'll come back to that. But now you can see from here down, I have to add 0 to the x. And that's this property right here, the additive identity. Because you have to leave 0 there. It doesn't just go away. You have to actually add it. So x plus 0 is x. And that would be the additive identity. So do you see like in the middle of a problem where you potentially use this? It's on an equation when something cancels out and you still have zero sitting there and you add it. All right. Questions on any of the problems so far with the properties name? Now, multiplicative is a little bit different. How we would see multiplicative identity, not additive. Multiplicative identity is when you do a problem and you're getting down and there's a number in front of an x, right? So something like this. Like I'll give you two examples of multiplicative identity. 3x plus x plus 4. Well, I have to add these x's together, correct? What's the number in front of it? The 1, right? So when you put a 1 there, you just did the multiplicative identity. You just multiplied by 1. So on a math problem, usually I always start with multiplicative identity first. If I know that, like when I look at the problem, I know that I'm going to have to add x's together, or like subtract them or whatever I need to do. But there's no number in front of one of them. I'll introduce it like the first step. Oh, it's a multiplicative identity. That's my first line. I want to introduce the 1 there. That way I can actually use that later. Or you're in the middle of an algebra like equation, something like this. So, you divide both sides by 2. This side, so that's division, property of equality. This side is substitution, where I make the 4. Because that's just random numbers being divided. But over here, this is a special property makes 1. That's a different property name. We'll get to that here in a second. That's one of the inverses. It's kind of like the problem I did over there earlier. So this is 1. But now in the next line, going from here down, I actually have to multiply 1 on the x, which just makes x. So this is the multiplicative identity. I multiplied by 1. See there when you introduce a 1 or you multiply it? Multiplicative identity. Okay. Any questions where you can potentially see that property? You multiply by 1. Okay, so not bad. So these are pretty straightforward. It's just they're in the middle of an equation or an algebra problem where you're solving for a certain variable. That's kind of where you see those two most of the time. But again, it looks like simple arithmetic, right? It looks like you're just adding 0, you're multiplying by 1. It looks like substituting, but it's not because 0 and 1 are special, so those are its own properties. So you got to separate these from substitution. Separate. Okay. Questions on 4, 3, 2, or 1 for the field problems? Any of those up above? Okay, last one I want to talk about today, the last problem. I want to talk about this inverse property. There's 2 of them. Now, I'll scroll down on the page here so you can see this. Okay, so for the inverse properties, there's the property of opposites. This is one of them. And in fact, I'll scroll here. And then the other one's called the reciprocal. And in fact, I actually have them on the board. I just didn't label them. Okay, so let me scroll here so you can see these. All right. So here's the 2 properties, and I know it's a little bit hard to see. Okay, so the 2 properties, property of opposites and the property of reciprocals. Now, what I just call them, prop of op, and I just call this one reciprocal. I don't call it properties. But they're inverses. That's what you need to realize. These help you, like on an algebra problem, to solve for something. So, the property of opposites. It's when you add numbers together or subtract them, and they make 0 every single time. Okay, now where you see this in a book, negative A or A, those are called opposites, but it's called an additive inverse. That's sometimes what it's called, but it's called the property of opposites. In fact, I did it right here. Going from this line down, where I took 3 minus 3, and I made 0, right? That is the property of opposites. Property of opposites. It's when you, it's every time on an equation when you're like adding numbers to both sides or subtracting numbers to both sides, and it makes 0, like one of the numbers on the like the left or right side cancels out completely. You just did the property of opposites. You actually make 0. And then from there, I can add 0 to something, which would be the additive identity. So the thing is, when you do a property of opposites, when you make 0 on a problem, it's usually followed by an additive identity. You have to like add a 0 off of it. So they kind of go hand in hand. That's why I always said, I think the inverse properties would be above the identities, because you would do one of these first, and then the identity would come right after it. Okay, so that's the inverse property. That's property of opposites. It's when you're adding or subtracting to both sides, and something cancels out and makes 0. Okay. Now the property of reciprocals is when you're dividing by something, and it makes the number 1. So you can either multiply by the flip, that's what the reciprocal is, right? Or you're just dividing numbers to both sides of the equation. Okay, so over here, on this problem I did earlier, this side, I divided both sides by 2, fine, that's division property equality. This side is substitution, making the 4. But right here, going from this step to this step, do you notice where I did 2 divided by 2? That isn't substitution, because I created the number 1 here. This step, dividing these two numbers and making 1, that is the reciprocal property. That's the property I just labeled on the board there. It's when you divide numbers and it makes 1. Okay, so that's the difference. Now, most people, when they think of reciprocals, they think of something like this. So if I give you a fraction, a reciprocal to this fraction is flipping the fraction over. Okay, that's what a reciprocal is. But when you multiply them, you get the number 1 every single time. Because what happens when you multiply fractions, you can actually simplify up and down, which these don't actually simplify, or you simplify diagonally. That's something that you learn. So when I simplify diagonally, these divide out to make 1s, these divide out to make 1s, and now your answer on the top is 1 times 1, 1 times 1, and you make the number 1 every time when you multiply them together. That's just something you need to realize. Well, that's what's happening here. On my original problem, the original problem that was 2x equals 8. What I'm actually doing is I'm actually multiplying both sides instead of dividing, if you want to think of it this way. I'm actually multiplying both sides by this reciprocal. So what's the number 2 as a fraction? 2 over 1, right? So this 2x is the same as 2 over 1x, or 2x over 1, that type of thing. Well, what I'm doing is I'm actually multiplying both sides by half. That's what I'm actually doing. I'm multiplying both sides by the reciprocal. It's still the same as dividing. This is the same thing, dividing both sides by 2. Because what you technically do is you multiply straight across. So that would be 2 over 2x. And then over here, 8 times is 8 over 1, so you multiply straight across, so it's 8 over 2. That's why it's the same thing. These are the same. Multiplying by the reciprocal works. And that's why this makes 1 and why we call it a reciprocal. This is what I'm actually doing there. That's what a lot of people don't realize. Like, dividing and multiplying they're actually the same property. Because you either multiply by the reciprocal or you just divide by number. That's kind of the idea. Okay, so those are the basic properties you should have up to this point. Okay, that's every single property other than distribution. Okay, distribution is one we're going to really focus on tomorrow. Now, I know you guys know how to distribute correctly, but I'm talking about like when you distribute, you have to closely follow distribution with these properties when you're actually solving. So this is the stuff we have to put these all together in the middle of the math problem to actually solve these things out. Okay? All right. Questions, comments on any of these properties so far? Okay. Tomorrow for sure we're going to hit distribution. I want to focus on that one tomorrow for sure. We'll do kind of a bunch of examples. I'm going to hand out your property sheet tomorrow because I have your handout for that. So you'll have all these properties on a sheet so you can use it for homework and tests and whatnot. We'll probably have an assignment maybe Thursday this week where we have to do everything, every single property. And I'll kind of walk you through that as we go. We'll try to focus on Wednesday on distribution, but Thursday when we put this all together. Okay? All right. questions, comments on anything so far? Okay, I have one example, and we're done for today. One example. This is what I want you to put in your notes. This is the final problem for this. So this is doing an equation, and we're going to put all the pieces together for it, so you can see how this works. So now, solving for a variable, putting these properties other than distribution, because we don't need that for right now. But showing commutative, showing symmetric property, substitutions, properties of equality, these property of opposites and reciprocal, doing the identities, that type of thing, like putting it all together for this problem. So let's go 2x minus 1 equals 9. Just some simple algebra 1 problem. And most people know how to solve it in like 3 seconds in their head. The answer would be 5. We know that in the very end. How to solve that out. But what I introed last Tuesday, actually a week from today, last week, I showed you that every time I give you one digit on this equation, so like one digit would be like this number right here. That's a digit. To get rid of that single number, it takes 4 lines of work. 4 steps. All 4 properties get there. It's the same 4 properties every time. Okay? So I'm going to walk you through the outline. So what our goal is right now is to get rid of that number 1, because we want to get the x by itself. So the order that I'm thinking of is this. When you're solving equations, this is the order we go in. SADMAT, right? It's PEMDAS, the order of operations backwards. It's inverse operations, right? So we're going to add and subtract first, we'll multiply and divide, and we'll do exponents and parentheses if we have to. Well, we can add and subtract first. That's the one. Okay, but here's the outline of how it's going to work. When we first start a problem, we have to start with some property of equality. That's what we're going to start with. We're going to start with some property of equality to get rid of that number. Okay? On one side, we'll substitute. We'll do some simple substitution because we'll do some simple math on one side of the equation. On the other side, we're going to do some type of inverse property. What I mean by inverse property, it's going to be something like property of opposites, it'll be reciprocal, it'll be something. Okay, and then what we'll do is right after that inverse property, so it's either property of opposites or reciprocal, we'll follow that with an identity. And that's how you get rid of one digit. I don't know why, it's always these 4 steps in order. Okay, so let's think about this out loud. We're going to go through this problem right now. Okay, so we're going to start with the first line. What do I have to do to both sides to first attempt to get rid of that negative 1? Add 1. That's my property, right? I'm going to add 1 to both sides. So what I just did there, I did the additive property of equality. I added. Or you can write addition property of equality. I'm fine with that. Okay, does that make sense like the first line? Most people will go, oh, I have to add. Well, that's your property. It's additive property of equality. Okay, on one side, I have to do substitution. So left or right side? Which side is the substitution line? Right side. Over here. 9 plus 1 is 10. That's substitution. The other side, I'm not going to mess with it. Negative 1 plus 1. So I did the substitution. That's 9 plus 1. That's just random numbers added together. On the other side, I'm doing an inverse property. Because what's negative 1 plus 1? 0, right? So this is 0. Now, making 0, that's special. That's an inverse property. If you look at up the board, which one is it? Is it property of opposites or reciprocal? Which one makes 0? Prop of op. So that's the inverse property. So instead of writing this, we'll write prop of op. Property of opposites. That's more specific. Don't write inverse, write the actual one. There's 2 of them. So when you create 0, that's property of opposites. And now the last line, we're going to be adding 0 here, right? So what's 2x plus 0? 2x, right? So now which identity is it? There's 2 identities. So I scroll up here, and in fact, if you just think about it, it's common sense. which identity it is. There's two of them. Which identity is it? Is it additive or multiplicative? Additive, because what am I doing with the 0? I'm adding, so that's why it's an additive identity. There, boom. 4 lines of work, I got rid of the number 1. The negative line, I should say. Now, how many lines of work will it take me to get rid of the 2? 4 lines, in that exact order again. There'll be some property of equality, there'll be some substitution line, there'll be some inverse property, so it'll be probably reciprocals, and then it'll be some type of identity, probably multiple. Okay, so what I want you to do, try to finish those last 4 steps by yourself. Let's see if you can get rid of the number 2 with these 4 steps in that exact order to get rid of the 2. Keep going. We'll do about a minute or 2 here, and then we'll finish it. We're done for today. So what I'm going to do, it's going to be kind of fun, I'm going to throw a koosh ball at you. And whoever gets the koosh ball, you have to tell me the next property name of what we're doing. Okay? It's going to be kind of fun. Somebody's got it. Who's picking it up? Brittany's on. She just volunteered. All right, Trevor, what do you got? What's the next property? Okay, good. Now you get to throw it to the next person. So that is division, property of equality. All right. All right, so that's division, property, equality. I agree with that. Next one. Okay, so substitution. Now, what's my substitution line? Which side? Right side. 10 divided by 2 is? 5. Okay, so I agree with that. And you said substitution. All right, for the ball to somebody else. She called it. All right. It's on your desk, so you can't avoid it now. No, Sadie's on it. You're a volunteer. All right, so look at the board. So what type of property are you doing next? So, what does it say in red? Inverse property. Now, which one? Is it, let me scroll here. Is it property of opposites or reciprocals? We only have 2, so you got a 50-50 chance. Now, let me kind of walk you through this. Property of opposites, when you're adding numbers to make 0. On reciprocals, you're dividing. What are we going to do on the left side there? Divide. So which one is it? Reciprocals. All right. So now, 2 divided by 2 is 1. All right. Good. So, and that is a reciprocal property. Okay, that's good. All right. Sadie, you can throw it to somebody else now. All right. All right. So your the next line. You don't need to divide by 1, because we have a property for that. Merge that. We scroll up. It's one of the identities. So it's either adding a 0 or multiplying by 1. Which one is it? Multiplicative. So we're going to multiply by the number 1, and that gets rid of it. And you're right. That is the multiplicative identity. Okay. You see how it's the same 4 lines? It's a property of equality, a substitution line, some type of math, or some type of inverse. There's only 2. So you got a 50-50 chance. Are you either adding or are you dividing? So we divide on this one, so it's reciprocal there. And then we always end with an identity. It's either additive identity or multiplicative. That's how we get rid of 1s. And most people, they always attempt to multiply by 1s, right? Or divide by 1s. You wouldn't need to. We have that little property that gets rid of 1. Okay? Okay, you see how it's always 4 lines. We're going to practice this again tomorrow. Okay, and we'll try to throw the ball to some new people this time. That's how ladies will later. Alright. Well, alright, let's go. Let's go. Alright. Okay, you guys are done for the day. I'll give you a property sheet tomorrow so you have it. If you haven't been to the website, I do have the property sheet, this one, on the website, so you can always open it if you want. You can print it out yourself, but I'll give you a copy tomorrow so you can use it for homework. Page 139 is due. That's due today. If you have not already, make sure your name's on it, everything. Never has to be avoided.
Yeah, I'm picking it up. Picking it up.
No, not picking it up.
Not picking it up.
That makes me happy.
No one wants it. You got it twice, so be happy.
I want it.
You should have just popped it in there and been like, oh, wow, it's me again.
Okay.
Picking it up.